SpaceX engineers are in complete shock. The heat shield crisis is destroying everything. 18,500 tiles, failing every flight. $1 million burned per mission. Mars dreams dying. But Elon's desperate steel gamble could save it all. Or kill the program forever. Will this insane bet work? Let's dive right in. Picture this. You're an engineer at SpaceX, staring at footage from Starship Flight 4. The ship is returning from space when suddenly, fireworks. Not the celebration kind. Our multi-billion-dollar heat shield is literally disintegrating kind. Chunks of ceramic tiles are ripping away from the ship. Superheated plasma is eating through the hull like acid. The flap hinge area becomes a light show that would make the 4th of July jealous. This wasn't supposed to happen. Not like this. Every engineer in that room knew they were watching the moment that could kill Mars' dreams forever. Because here's the brutal truth nobody talks about. If you can't solve re-entry, you can't reuse rockets. And if you can't reuse rockets, Mars is just an expensive fantasy. But there's something even more terrifying about this footage. For months, SpaceX had been telling everyone that ceramic tiles were the solution. After all, they worked perfectly on Dragon capsules. Government officials were convinced. Investors were satisfied. Even NASA was impressed. But Dragon is the size of a small car. Starship is a 20-story skyscraper. The physics don't just change, they become your worst nightmare. When Dragon re-enters Earth's atmosphere, it's dealing with about 70 square meters of surface area. Manageable, predictable. When Starship re-enters, we're talking about over 1,000 square meters of pure hell. That's not a 14 times increase in complexity. It's exponential chaos. Every single tile becomes a potential failure point. Every gap between tiles becomes a plasma pathway. Every vibration during launch creates microscopic cracks that turn into catastrophic failures during re-entry. SpaceX engineers discovered something that kept them awake at night. Scaling up heat shield technology isn't like scaling up a recipe. It's like trying to turn a campfire into a controlled nuclear reaction. But the real kicker? They didn't know how bad it was until they saw the footage. Here's the number that made SpaceX executives consider early retirement. $1 million per flight for heat shield maintenance. Think that's expensive? It gets worse. SpaceX wants to fly Starship weekly. That's $52 million per year. For one ship. They're planning dozens of ships in their fleet. Do the math. We're looking at over $1 billion annually just to keep ceramic tiles working. That's more than the entire budget of some space agencies. But money isn't even the worst part. Each inspection takes 3 weeks. 3 weeks of engineers crawling over every square inch of the ship with magnifying glasses, looking for cracks, chips, and missing tiles. 3 weeks of delays while other ships wait in line. SpaceX's dream of rapid reusability was turning into a ceramic tile replacement service. And then engineers discovered the hidden killer. Nobody expected this. The heat during re-entry? Sure, that's obvious. But the thing that's actually destroying ceramic tiles happens before the ship even reaches space. Launch vibration. When 33 Raptor engines fire simultaneously, they create seismic-level vibrations. The entire ship shakes like it's in an earthquake. Those delicate ceramic tiles held by tiny metal pins start developing hairline fractures before they even face their first bit of heat. It's like sending a porcelain vase through a paint mixer and then expecting it to survive a blowtorch. Data from post-flight inspections revealed the horrifying truth. Most tile failures weren't from re-entry heat, they were from launch vibration. The tiles were essentially pre-broken before they had to do their job. This discovery sent shockwaves through SpaceX. They weren't just fighting physics, they were fighting their own rocket. But then came the announcement that stunned the aerospace world. We're going back to steel, Elon announced in a closed-door meeting that would leak weeks later. Engineers thought he'd lost his mind. Steel? For a heat shield? That was the abandoned 2018 plan. They'd moved to ceramics for good reasons. Steel conducts heat. Steel is heavy. Steel seems like the exact opposite of what you want protecting a spacecraft during re-entry. But here's what changed everything. Failure analysis data. While ceramic tiles can handle 10 to 50 megapascals of stress before cracking, steel can handle 500 to 700 megapascals. That's not just better, that's 15 times more durable. Launch vibration that destroys ceramics, steel laughs at it. Thermal expansion that cracks tiles, steel flexes and returns to shape. Impact damage from debris, steel gets scratched. Ceramic gets obliterated. But there was still one massive problem. How do you keep steel from melting? This is where SpaceX's secret weapon emerged, transpiration cooling. Imagine your skin sweating to cool you down. Now imagine that happening on a spacecraft traveling at Mach 25 through superheated plasma. Liquid methane flows through microscopic channels in steel panels. As the ship heats up during re-entry, methane evaporates and carries heat away. The steel stays cool enough to maintain structural integrity. It sounds like science fiction, and for 60 years it was. NASA tried it in the 1960s. Failed. The Soviet Union attempted it. Failed. Every major space agency has thrown millions at this technology. Every single one failed. Why? Because getting liquid to flow evenly through microscopic holes while experiencing 5 Gs of acceleration and 1,500-degree temperatures is like performing surgery during an earthquake. But SpaceX had something nobody else had: 3D metal printing technology that could create cooling channels inside solid steel. Here's what SpaceX hasn't told anyone publicly. They've been testing steel heat shield panels for over 18 months, not on Starship, on smaller classified test vehicles. The results were mixed. Early tests showed promise, but cooling channels kept clogging. Methane flow became uneven. Some panels warped under extreme heat. Engineers were about to recommend abandoning the steel approach entirely. Then came test number 47. During a high-temperature simulation that would instantly vaporize ceramic tiles, a steel panel with integrated transpiration cooling didn't just survive, it got stronger. The panel actually improved its heat resistance as temperatures climbed. Something about the controlled methane flow created a protective barrier that made re-entry conditions easier to handle, not harder. That single test result made Elon bet everything on steel. But there's a deeper reason for this desperate gamble. Mars. On Earth, you can manufacture ceramic tiles in clean rooms with precise equipment. On Mars, you'd need to ship an entire ceramic manufacturing facility across 200 million miles of space. Steel panels? Mars has iron ore. Lots of it. Future Mars colonists could literally mine the materials for heat shields from the ground beneath their feet. They could manufacture replacement panels using basic metallurgy equipment that weighs a fraction of ceramic production facilities. This isn't just about Earth operations. It's about making Mars missions truly self-sustaining. Ceramic tiles doom Mars colonies to dependence on Earth supply runs. Steel panels make them independent. SpaceX faces an impossible timeline. They've publicly committed to catching the upper stage by 2025. That's less than 4 months away. But you can't catch a ship that's shedding debris during re-entry. The ceramic tile fragments would damage Mechazilla's arms. The ship might disintegrate before reaching the catch zone. Steel heat shields aren't just an improvement. They're absolutely critical for upper stage recovery. Without them, SpaceX's entire reusability plan becomes worthless scrap metal. Here's where it gets insane. SpaceX is planning to test steel heat shield sections on Starship Flight 10. Not the entire ship, just critical areas. If those sections fail catastrophically, they'll know steel won't work. Years of development wasted. Mars missions delayed by decades. If they succeed, Flight 11 could feature the first fully steel-protected Starship in history. The aerospace industry is watching this test like a boxing match. In one corner, 60 years of ceramic heat shield tradition. In the other corner, SpaceX's impossible steel gamble. Winner takes the future of spaceflight. Boeing engineers are calling it reckless. Blue Origin thinks it's a dead end. ULA believes SpaceX is about to learn an expensive lesson about why ceramics exist. But NASA is quietly interested. Because if SpaceX cracks transpiration cooling, every other space company becomes obsolete overnight. Imagine heat shields that last hundreds of flights instead of 3. Imagine manufacturing replacement panels on other planets. Imagine launch costs dropping by 95%. That's not competition. That's extinction for everyone else. Here's what nobody's talking about. SpaceX may have already solved the biggest transpiration cooling problem. Recent Raptor 3 engines use integrated cooling channels that work flawlessly. The same 3D printing technology, the same methane flow control, the same impossible metallurgy. If Raptor 3's cooling system scales up to heat shield panels, SpaceX just turned science fiction into engineering reality. But there's one detail that makes this even more remarkable. Current ceramic tiles, $20 to $50 each, times 18,500 tiles, nearly $1 million per ship. Steel panels with transpiration cooling, $2.80 per kilogram of raw steel. Even with complex manufacturing, maybe $200,000 per ship, but the real savings come from reusability. Ceramic tiles last 3 to 5 flights. Steel panels could last 300 to 500 flights. We're not talking about minor cost savings. We're talking about reducing heat shield costs by 99%. That single change could make space travel cheaper than commercial aviation. But here's the terrifying reality. SpaceX is running out of time. Flight 7 used Block 2 hardware, but still had ceramic tiles. Flight 8 will likely test steel sections. Flight 9 might feature full steel coverage. Each test brings them closer to the answer, but each delay pushes Mars missions further away. Competition is heating up. China is developing reusable rockets. Europe is planning Mars missions. Russia is building new spacecraft. SpaceX's window for Mars dominance is shrinking. Steel heat shields aren't just about engineering excellence. They're about winning the space race. While everyone debates whether transpiration cooling will work, there's one question nobody's asking. What if SpaceX has been testing this technology longer than anyone realizes? What if the real breakthrough happened months ago, and Flight 10 is just the public demonstration? What if the steel heat shield crisis is already solved? So here we are. SpaceX engineers shocked by their own heat shield crisis? Steel technology that could revolutionize spaceflight forever, or fail spectacularly in front of the entire world. The next few months will determine whether humanity becomes a multi-planetary species or stays trapped on Earth for another generation. But here's what really gets me thinking. While we're all focused on whether steel heat shields will work, SpaceX is already planning something even bigger. Block 3 Starships with 42 engines, Australian launch sites, orbital refueling stations. They're not just solving the heat shield crisis, they're building the infrastructure for an entire spacefaring civilization. Which brings up the ultimate question, are we witnessing the birth of humanity's spacefaring future, or the most expensive engineering failure in history? Let me know what you think in the comments. And if you want to dive deeper into how SpaceX's Raptor engines are making all of this possible, check out our complete Raptor breakdown next. The space race isn't over, it's just getting started. SpaceX and NASA just got absolutely destroyed. China secretly built a 3D printer that turns moon dust into buildings, while America was stuck in meetings. Russia's nuclear reactors are already powering Chinese lunar bases. The kicker? They'll control the moon's south pole, where all the water and rare minerals are, by 2030. 3 years before NASA even gets there. But here's the terrifying part nobody wants you to know. Whoever controls the moon controls all future space missions to Mars and beyond. Are we watching America lose the space race forever? Let's dive right in. While SpaceX celebrates Raptor 3 engines and NASA announces another Artemis delay, China has been quietly operating the most advanced space laboratory humanity has ever built. But Tiangong isn't what they're telling the world. Everyone thinks it's just another space station doing science experiments. Dead wrong. Tiangong is a weapons factory for lunar domination, and it's been perfecting technologies that make SpaceX's achievements look like high school science projects. Here's what's really happening up there. Every single day for the past 3 years, Chinese astronauts have been mastering something called ISRU, In Situ Resource Utilization. Translation? They can build entire cities using nothing but dirt from wherever they land. In 2018, they became the first humans to 3D print ceramics in zero gravity. Sounds boring. This breakthrough just eliminated the biggest obstacle in space construction: shipping materials from Earth. Their latest prototype uses concentrated solar energy to melt lunar soil into solid building blocks. Roads, landing pads, entire bases, all made from the ground beneath their feet. But here's the terrifying part. While SpaceX burns billions on rocket fuel to transport construction materials, China just made that entire business model obsolete. The cost advantage isn't just significant, it's game over. For decades, NASA has recycled oxygen using the same outdated electrolysis process that consumes 1/3 of the International Space Station's total power. Expensive, inefficient, and completely obsolete as of 2024. China's astronauts just tested artificial photosynthesis in space, converting carbon dioxide directly into oxygen and rocket fuel using semiconductor catalysts. The process works at room temperature and uses almost no energy. This isn't just an improvement, it's a complete technological leap. Think about what this means. Every NASA mission plan assumes massive fuel requirements, complex supply chains, and limited mission duration. China's technology makes those assumptions worthless. They can refuel anywhere, stay indefinitely, and expand without Earth's support. While Raptor 3 engines are impressive, they still need fuel shipped from Earth. China's ships can manufacture their own fuel from atmospheric CO2. That's not just an advantage. That's technological superiority that makes SpaceX's reusability look primitive. Here's where the partnership gets terrifying. The moon's day-night cycle lasts 28 Earth days, 14 days of blazing sunlight, 14 days of deadly darkness at -250 degrees Fahrenheit. SpaceX's solar panels? Useless for half the month. Tesla's batteries? Dead weight that freezes solid. Nuclear power is the only solution, and Russia builds more nuclear reactors than the rest of the world combined. Rosatom isn't just designing a lunar reactor. They're building a fully autonomous nuclear power plant that requires zero human assembly. No maintenance crews, no safety inspections, no political approval processes. Just pure, reliable power running 24/7 for decades. This nuclear advantage doesn't just power small research outposts. It enables industrial-scale mining operations, massive construction projects, and permanent human settlements. NASA's solar-powered camping trips will look pathetic compared to China's nuclear-powered cities. And here's the kicker: Russia's